Hi, my name is PK Gulati. I'm the founder of The Assembly. If you're here, you're probably watching an assembly workshop. We do these workshops every week, and these are prepared by the assembly team in Dubai. These workshops cover ideas from data sciences, hardware design, automation, robotics, drones, and all the other exponential technologies that you can think about. The idea is for us to learn more than what curriculum teaches us. And we are trying to bring people to start working with their own hands with these technologies which have the capacity of changing the world. So welcome to this workshop and learn more about new wonders, what you can build.
Good morning, everyone. My name is Ajib Arshad, and welcome to today's workshop. So in this workshop, we're going to learn how to make a line tracking robot car, and it will include the installation process, assembly of the robot car, and also the coding part. So let's get started. Alright, so I'm going to start the workshop by giving you a brief about what the assembly is. So basically, assembly is a smart lab based out of N5 since December 2014. And since then, we have run over 300 free workshops. So we have three different kinds of workshops. So they're divided into three categories. The first one is hack, and then the second is code, and then the last is data science. So hack is about embedded systems, IoTs, hardware, and code contains software projects such as APIs, frameworks, and applications. And data science workshops are about artificial intelligence and machine learning. So our target audience are basically students, professionals, and entrepreneurs, or anyone who wants to learn about new technology. And the focus is on smart technology and its practical applications. You can also visit us on members.theassembly.ae to stay up to date with the latest updates. And here's our social media, so you can follow us on Facebook, Twitter, Instagram, and YouTube. I'm going to give you an overview of what today's workshop is about. So we're going to make a line tracking robot car using line tracking sensors, and we're going to go through line by line code description and also the assembly process of the robot car. So in this workshop, you will be learning a bit of Arduino programming. You will learn about how to design a robot car and assemble it onto the chassis, and also you'll learn how to work with sensors. So as you can see in this picture, that's the robot car that we're going to make. So it consists of 5 tracking sensors, and then it contains power supply, and we're going to talk about all the components in the next few slides. So yeah, it follows a white line, and then it changes its direction accordingly through the code that's given to it. So this is the line tracking sensor that we're using. So the sensor works by detecting reflected light coming from its own infrared LED. So by measuring the amount of reflected light, it can detect the transitions from light to dark or even objects in front of it. So as you can see, there's a small switch. You can tighten it or loosen it and to increase its sensitivity. So it depends where you're keeping the sensor. If it's very close to the ground, then you can decrease the sensitivity, and then if it's a bit high above the ground, then you can just decrease it. And it has 4 pins, which are VCC, ground, D0, and A0. So for this car, we're only going to use VCC, ground, and D0. We're going to leave A0 empty. So VCC is obviously giving the power to the component, and ground is just grounding it. D0 is giving it the signal. It's how it's communicating with Arduino board. So external hardware that's required is Arduino UNO board, obviously, and then you'll need 4 DC motors. You will need a motor driver to run the 4 DC geared motors. You will need 6 tracking sensors, which are gonna detect the light, and so that the car can follow it. You're gonna need 3.7 volt lithium polymer batteries. because the car needs at least 7.2 volts to run properly. If it's less than that, then the car will not work as desired. Then you will need a power connector, which is going to power both the Arduino board as well as the motor driver. Then a voltage meter, it's going to indicate the voltage that's being supplied to the car. Jumper wires to make the connections, robot car chases, which can be 3D printed, or you can just purchase them online. It's basically used to mount all the components all together to make one car. And then obviously wheels to enable movement. So this is the installation process of the Arduino board and the motor driver onto the chases. So the connections made to the motor driver are pretty simple. So the four geared DC motors are connected on the opposite side, and there are 4 ports on the motor driver: K1, K2, K3, and K4. So the connections are made where the motor is. So it's yeah. And then the motor driver, it's the 12 volt is going to be, the ground is going to be connected to the power supply using a power adapter, and then it's going to be connected to the Arduino board. So both of them are going to be powered through the same batteries. So here's the assembly and circuit setup of the line tracking robot car. So these are 5 line tracking sensors, and in the picture on the right side, top right side, you can see where they are placed. So left 1, left 2, left 3, left 4, and left 5. That's how the coding is done. So left 1, left 1's D0 pin is connected to pin number 3 of the Arduino board, and then left 2's pin is connected to A1 of the Arduino board, and left 3's D pin is connected to A2 of the Arduino board. Left 4 is connected to A3, and left 5 is connected to D10 of the Arduino board. And all of them have the same VCC, so it's all connected to 5 volts in the Arduino board, and the ground is connected to ground. So it's pretty simple, but you have to be very careful when you're connecting the D pins, because that's what enables the movement. So if the pins are not connected, like to the right port, for example, left 1 is not connected to pin 3, then the car will work in the opposite direction, and the result will not be the desired. So yeah, just make sure about that. So the software requirement and installation process, we're gonna provide you with the code in the description below. So you can download the latest version of Arduino IDE from their website. The code, and then you connect Arduino UNO to PC with USB cable. Open Arduino IDE, click File, and then Open. Choose tracking.ino in line tracking folder and load the code into Arduino. And then choose corresponding board port for your project. Upload the sketch to the board. Alright, so now let's start the assembly process of the line tracking robot car. So for the robot car, we will be using 5 of these tracking sensors. We will be using 4 DC motors, Arduino board, and power supply cable, power supply, and the motor driver. That's all we need. So now I'm going to be starting off with the assembly process. So as you can see, I have previously installed a motor driver shield onto the lower chassis of the car. I've installed 4 geared DC motors, and I have also installed 4 of the 5 tracking sensor modules. It's very simple installation process. You can install it on your own chassis if you want. And then we're going to use an Arduino board. As you can see, I have this upper chassis also has an ultrasonic sensor mounted onto a servo motor. So this was for the previous workshop where we made an obstacle avoidance robot car. So for this workshop, we will not be making the connections of the servo motor and the ultrasonic sensor, but it's just mounted on top of that. We will use the voltage meter and we will use the buzzer. So let's start off with the connections. So firstly, I will just connect this tracking sensor onto the chases before I start off with the connections. So 4 of them have already been connected. Now I will just make the connection to the last one. So I'm using a bolt, and then I'm using a washer to protect it from the bottom, and then I will just make the connection here. Alright, now these 5 tracking sensors have been placed. On the motor driver shield, these 2 wires have been connected to the ground of the motor driver shield, and they're going to be connected to the power supply cable with the main power supply of 7.2 volts. So we will leave that for now. So these 4 geared motors are connected on the opposite side, like on the port that is respective to its direction. So the motor driver shield has 1, 2, 3, 4 ports. So there's K1, K2, K3, K4. So for example, this one will go to this one will go to the one next to it, this one will go to this one will go to the one next to it. So it's a very simple process for this. So these 4 motors have been connected. Now I will make the connections from the motor driver to the Arduino board. So this upper chasis will go on top of the car like this. But before that, we need to make all the connections and pass the wire through these holes just to make it look more neat. Alright, so first of all, I will connect the wires. Again, as you can see, these wires have been connected to enable B, input 4, 3, 2, 1, and input A. So I will be keeping note of which wire is in which port according to their colors. It's much easier this way and faster. This way you won't have to keep passing the wires through through the spaces. So you will just do it once, and then you can just easily distinguish the ports according to their colors. Alright, so now they're out from the space. Now I can easily see the connections. So the first wire is white, which corresponds to enable B. So this wire will go to number 6 of the Arduino board. So now we can just make the connections very fast and easily. Then there's input 4, which goes to pin number 8. Input 4 is the gray wire, which is this one. We'll go to pin number 8. Then there is input 3, which goes to pin number 7. Input 3 is the purple wire, goes to number 7. Yep. And then there's input 2, which goes to number 4. Input 2 is the blue one, which goes to number 4. And then there is input 1, which goes to number 2. Input 1, which goes to number 0, 1, 2. And then there is enable B, which goes to number 5. Enable B goes to number 5, which is the red color, by the way. Yep. So the connections have been made from enable B till enable A and all the inputs. Now we will make the connection for the signal pin. So you can use any wire. We will connect the signal pin, which is the first one on the motor driver. The first one on S pin on the motor driver, that's going to be connected to pin number 10. Now we will make the connections for the line tracking sensors. So for the line tracking sensors, just to avoid a lot of chaos, we have connected We have 5 to 1 cable, two 5 to 1 cables, one for VCC and one for ground, to give them the same power, same voltage, and same. They all have the common ground. So we will connect all of the VCCs together and all the grounds together. Just look at the port and then you can just do it. So the first pin on the left is the VCC, so it's gonna be a little tricky on this side, but yep, gone in. Then there is this one, then this one. So all of them have been connected to this one wire, which will then go to the 5 volts on the Arduino board. So this is the 5 volts pin. That connection is done. Then we will connect the ground as well, which is the pin right next to it. And then this ground will be connected to the ground pin on the Arduino, which is right next to 5 volts. Alright, so now there are only connections to be made to the tracking sensors and to the voltage meter. So these are the only 2 connections left. We have connected the VCC and the ground pins. Now we have to connect the signal pin. So let's start off with the left one. So these are named as left 1, left 2, left 3, left 4, and left 5. So the coding is done according to those numbers, so just make sure. So left 1, you just connect it to the D0 pin. We leave the last pin empty. So this will be connected to pin number 3 on the Arduino board. Then we will connect left 2, which will go to pin number A1 on the analog input. Then left 3 will go to A2, analog pin 2. Then left 4 left 4 will go to pin A3, and then left 5 will be connected to pin number 10. So these are the connections for the tracking sensors. Now the only connections left are to the voltage meter, which are very simple. So the voltage meter has 3 pins, VCC, ground, and VT. So VT will be connected to 0 volts on the motor driver shield. The last few pins, it's very difficult to see, but they're on the motor driver shield. So there's ground, 12 volts, and 0 volts. So the VCC will be connected to the 12 volts. VT of the voltage meter will be connected to 0 volts, and ground will be connected to ground. So the pink one is the 12 volts, which goes to the VCC. Then orange is the ground, and 0 volts is the white wire. So that's all the connections. There is one more, which is the power supply. So let's just... So these 2 wires are connected to the motor driver's ground, which I showed earlier in the start of the video. So these 2 will go inside this. So it has a plus and a minus. So plus, the red wire will go to the plus, the black will go to the minus, and in the same power cable we have created this supply, which gives it a voltage of 8 volts. So any voltage above 7.2 So the voltage should be more than 7.2, and then the car will work accordingly. So so in the positive, we have connected these 3 batteries and a power bank in series to generate enough voltage. So in the same plus, you plug in the power supply and then tighten the screw. So now the same power. So now it will power both the Arduino board and the motor driver shield. So the connections are made. We will put in the screws. And now we will just connect the tires, and then we are done. So that's it for the connection video. You just now plug in this USB cable into this, and then the car will start. Alright, so here's the code for the line tracking car. So we're gonna start with include configure.h. So configure.h, it's a file that we made to store all the initial values and definitions for each pin, and we will talk about it later in this description. So we're gonna start with sensor 5 because there are going to be 5 sensors, which are the data type is char, which means character, and then so basically the function is read sensor value string. 1 stands for black, 0 stands for white. For example, if the serial monitor shows 1 0 0 0 0, that means that the first sensor from left detected a black line and the other 4 sensors detected the white line. So that's a functionality. So we're gonna start with this function. So string read sensor values, that's a function. So inside the function we have defined sensor value as 32, which is given an integer value. So there are 4 sensors: sensor 0, 1, 2, 3, and 4. 5 sensors actually, yeah. So these 5 sensors, they're given specific pins on the in the configure.h file. For example, sensor 0 is connected to 3, sensor 1 is A1, A2, A3, and sensor 4 to 10 respectively. So we're gonna see sensor 0 is so we read the value coming from sensor 0 and then store it in sensor 0, and then we store the value coming in from sensor 1 into this variable, and the same for the next 3 sensors as well. Finally, the sensor value that we defined in the first step, 32. Now we increase it. So plus equal to means sensor value is equal to sensor value plus this entire line of code. So we add the value of sensor 0, 1, sensor 2, 3, and 4, and we multiply it with 2 raised to the power of 1. For example, this is 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, and 2 raised to the power 4. And then we add it to the sensor value. Then we change the integer value, which is then we change the sensor value from integer to string, so that the serial monitor can show it. Yeah, then that's just the print in. So the serial monitor will show sen str, sen str, and then it will return this value in the form of a string. Now void go advance. This function is used to tell the car to move forward, so it controls the pins. So dir1 pin L, you can see that this pin is referred to the motor direction. So it's connected to pin number 2 on Arduino board. So just like that, all these pins that we are referring to in the main code are defined in configure.h file. So the same for this. So if the car is moving forward, then pin L and pin R of the back will be high, and then the left and right 2 will be low. So these are all, the code is kept the same, just the high and low values given using the digital write function it has been changed. For example, to turn left, and the code for the same dir1 pin L is given as digital write dir1 pin L, and it's set as low. So it's basically opposite of turn left. It's opposite of turn left. For example, turn left is high, low, low, high. Turn right is low, high, high, and low. And then for forward, it's high, low, and then for reverse, it's low, high, low, high. And for stop, it's obviously just all low. And then, so this function is to change the motor speed. So it has two inputs, which is speed underscore L and speed underscore R. So analog write function is used to to modify or change the speed, or give the speed to the car, so that it can move at that speed. So you can see the speed pin is connected to 5, and then pin L is connected to 6. So it needs to be a PWM pin to be able to control left motor speed, and this speed pin R controls the right motor speed, and it also has to be a PWM pin. So that's what has been defined here. And now this is the setup. So pin mode is used to specify if the pin is an input or an output. So we have set speed pin L, speed pin R, dir1 pin L, 2 pin L, 1 pin R, 2 pin R as all as output, because the first one is left motor PWM pin, and then speed pin R is right motor PWM pin, and then dir1 pin L is left motor direction, pin 1, and then this is pin 2 of the left motor direction. And yeah, the description is given here: right motor direction pin 1 and right motor direction pin 2. And then these are the line tracking sensors. These are all set as input because these sensors, they detect the white line, and then they send the information back in the form of a string of ones and zeros. So whenever it detects a white line, the serial monitor will show 1 for the respective sensor. So if it's 0, 0, 0, 0, 0, 0, 1, then that means the left 5 has detected a white line, and then the car will move towards the right to be on track. Yeah, as you can see, like in theme parks as well, you see these cars in which you sit, and then they just give you a tour of the entire place. So it's exactly the same process. Now this is the main function. So it's auto tracking. It's a void function, so it doesn't return anything. So we have defined the string variable sensor val, and we've equated to read sensor values. So it reads the sensor values coming in from the sensors. So these are the conditional loops that are given. So these are okay. So first there's an if function. So if sensor val is 1 0 0 1 0 0, you might notice that in the code, in every condition, there is always 1 in the front. So that 1 is just kept constant because the serial monitor, it's gonna show 6 values instead of 5, and the first one is just gonna ignore it because that's always gonna be 1. You just have to focus on the last 5 because there are gonna be 5 sensors. So if sensor val is equal to 0 0 1 0 0, that means that the line is in the middle. If there is 0, 1, 1, 0, 0, that means the line is on the left side, because the left two sides of the car have detected a white line. And the same for this one, the left three sides have detected a white line. And for this one as well, these are all the conditions that are possible to give if the car is if the line is on the left side of the car. So if the line is on the left side of the car and we're getting 0, 0, 0, 1, 1, 0 or 1, 1, 1, 0, 0 or 1, 1, 0, 0, 0, then that means the line is on the left, and then we will call the function go left, because the black line is in the because the white line is in the front, and the car needs to turn left to be in the middle, to bring the line in the middle. And then we can set the motor speed. The speed is given in configure.h, which is set to 180. You can change it from here. You can change it to whatever speed you want. And then we are calling a delay function, and then we're stopping the stopping the function. Then we're giving another if statement for if the line is on the right side. So if it's on the right, then 0, 0, 1, 1, 0, that means the line is on the right side, because the right two sensors are detecting the line. And the same for 0, 0, 1, 1, 1 and 0, 0, 1, 1, 0, 0, 0, 1 and 0, 0, 0, 1, 0. So then we'll again call the go right function, and we'll set the speed to 0. We'll set the speed, and then we'll call the delay function, and then we'll just stop the function. So it's gonna go right till we get 1, 1, 1, 1 or 0, 0, 0, 0. So if there's if sensor value is all ones or almost all ones, that means the car should stop. If so we'll call the stop function, and then the motor speed will set to 0. And if you want the car to keep going forward, you can just play with these values, and then you can for example, if in this code means that if the car doesn't detect a white line, then the car will stop. So suppose if you're using a black line, if you want the car to follow a white line, then you can set these to 0 instead of then you can call go advance function over here, and then the car will not stop, it will go forward, because this code we have written it to enable the car to follow a black line, because 1 stands for black, 0 stands for white. So that's why when it's all ones, the car will stop. So you can just change these values and change the stop function, or go right function, or go left function. All of them have been defined over here. So go back, go stop, or go left, or go advance. And then we have also given you an example. So for example, if it's 1, 0, 0, 0, 0 means the first sensor is detected the black line. So that's the basic understanding of the code. So you can just change these values and change what you want the car to do, and then you can just customize it according to what you need. And then if the sensor value is 0, 0, the car will go back. And then the motor speed, we are setting the motor speed, we're calling the delay function, and then we're stopping the car again. And then in the loop, we're just calling the auto tracking function, which we just defined. So I hope you all got the coding part. And in case there's something wrong with the serial monitor, or in case the car is not following the line properly, you can just tighten or loosen the screw that's on the sensor, and then the car will start detecting the line much better. So that's it for the coding part. Alright, so now I'm going to be powering the car, and let's put it on the line. So as you can see, we have prepared a white line. So let's see. As you can see, it has covered the white line and now it has stopped once the line has stopped. So it uses these 6 tracking sensors and they detect the white line and it changes its direction to follow the line. So that's it for today's video. If you guys like the video, give it a thumbs up. If you guys like our content, then subscribe to our YouTube channel, and thank you all for watching.